All right, we're going to continue with some multiplying. This time we're going to do the product of a two-term binomial times a trinomial. It's going to actually look like the monster claw. Take the 2, take the 2x, multiply it times the first, then the second, then the third. 2x times x squared is 2x to the third power. Add your exponents. 2x times negative 6x is 12x to the second power, adding exponents. 2x times 4 would be 8x. Then I'm going to take the second term, which is a positive 3, and I'm going to multiply it times the first. That gives me 3x squared, and I think I'll align it with the other x squared term. 3x, or 3 times 6x, would be negative 18x minus 18x. And then I'm going to have 3 times 4, which is 12. Now, I need to combine like terms, and since I've aligned them, it makes it easier to see. There's only one that has 2x to the third. Negative 12 plus 3, that's like positive 3, would be negative 9x to the second. You only add the numbers in front. Negative 10x plus 12. So when I look for negative 10 plus 12, answer C is correct. What is correct factorization of? First thing I'm going to do is always look for GCF first. That is my rule of thumb. Look for GCF first. What number, what letters do they have in common that I could factor out? Well, I cannot take out a letter because they all don't have letter X, but they do have 2. I can factor out a 2. So if I factor out a 2, there's 1, 2, 3 terms, 1, 2, 3 terms in parentheses. The signs are probably going to stay the same. Divide out a 2. So if I divide out a 2, all right, 2 goes into 4x squared 2 times, and there's also an x squared there. 2 goes into 14, so it's basically like dividing out a 2. Now I'd have 7x left, and here I'd have minus 4. Now, if I look closely, I'm going to ask myself, is it possible that this trinomial can factor? I believe it can, because 2x and x is the only combination that multiplies to give you 2x squared. I'm going to try 4 times 1, and I'm going to put the 4 in the end. Remember to check. You're going to do inners. 1 times x is 1x. You're going to do outers. 2x times 4 is 8x. And if I subtract, and if the last term is negative, I am going to subtract. I could end up getting a 7x. In order to do that, I need my 1x to be negative. So I'll put a negative there, and I need a plus here. If I just bring my 2 down, this is my factorization, 2x minus 1, and then x plus 4. 2x minus 1 and x plus 4, C is correct. All right, number 27. I'll have to erase what I just did, so I'll have room for the next problem. 27, what's the factorization of this one? This time, they all have x. Remember, you're going to try to take out as many x's as you can. So it looks like I can only take out one x because that's all that they all have. So take out an x, 3 terms. So it's like subtracting an x away. The signs are going to stay the same. I'm going to have x squared. I'm going to have the 4 still and 1x because I took away 1. And I'm going to have minus 12. That trinomial will factor. What multiplies to give 12 that subtracts to give 4 would be 6 and 2. The bigger number wins the sign of the middle term, so 6 is the negative and 2 is the positive. So it's minus 6 plus 2, choice A. All right, for the next one, so not multiple choice, you just have to work them out yourself. I'm looking at number 28A, and I recognize it as a difference of squares. So that would be 2x times 2x. That would be 9y times 9y. Parentheses, 2x and 2x first and first in the parentheses, 9y and 9y, 1 plus, 1 minus. That's my answer. I did need to supply that answer. There was not multiple choice. In part B, it is a difference, but it's definitely not just squares. So I'm going to do the first thing I can, and the first thing is always to look for a GCF. Sure enough, if I check, 15 is divisible by both, and I can take out 2 C's and 3 D's. I take out as many letters of each that I can from both things. Then I'm going to put in here what's left. So it's like I'm dividing out 15 C squared D to the third. 15 goes into 15 once. C2 from C4 is C to the second. 15 goes into 105. think that's 7 times c to the second from c to the seconds, no more c's, and d to the third subtracted from d to the fourth leaves me 1d. That is not factorable again, so I guess I'm finished after I do the GCF. 29. Factor. Now this is a trinomial, so I'm going to try to factor into two sets of parentheses, and I'm going to check the middle term. There's only one way to multiply and get 5x squared, and that's 5x times 1x. There's really only one way to get 2, and that's 1 times 2. I just need to be careful where I put the 1 and where I put the 2. If I put the 1 here and the 2 there, and I check inners and outers, remember this? I end up with 10x and 1x. When the last term's negative, I end up subtracting to get the middle term. That won't subtract to be 3. So 2 and 1 have to be used, so all I can do now is to switch places with the 2 and the 1. So let's put the 2 in the, put the 2 in the front and move 1 to the back, and I believe I have it factored. This is 2x, this is 5x, and I need the bigger number to bench the middle term, so I need the 5 to be negative, which means I need the negative here and the plus here. Now, that check step is very important. We did that a lot. I hope that you do it. Take time to do it. That is your solution for 29A. 29B, I'm going to look for GCF first, just like we try to do. 3 will go into all the numbers. They all have at least one x, and they all have one y. So, if I factor it out, there are 3 terms, so I know I'm going to have 3 parts. 3 goes into 3. X from x is no x, except for 2 of them, and y from y is no y's. 3 goes into 30 10 times. X from x squared leaves me with 1x, and y from y is no more y's. 3 goes into 75 25 times, and there's no x and no y. Now this actually will factor again. I'm thinking what multiplies to give 25, and when the last term is positive, I'm going to add to get 10. It turns out that I need a positive 5 and a positive 5. Those two parentheses turn out to be exactly the same. There is a shortcut way of writing this answer. I can say that it would be 3xy times one set of parentheses with x plus 5 in it. Then I can say squared, because that tells me I have 2 parentheses just the same. If you wrote it out, or if you wrote it squared, either of those ways of showing the answer is correct. All right. 30. First thing I'm going to do is do GCF. And when I do, I know I can divide everything by 4. So everything will be 4 times smaller in number. I'm going to keep my signs the same. 4 goes into 4 one time with x squares left. 8 is left and an x. And I have 12. Does this trinomial factor again? Let's just see. Is there anything that multiplies to give 12? And because the last term is positive, it's going to add to be 8. I believe that's 6 and 2. You have to be a negative 6 and a negative 2. Bring your 4 down. This represents the complete factors of 30, all the way as factored as far as we can. All right, letter B. Let's factor letter B. First thing, GCF. There's a lot of these that have had GCF. I always check for that first. I believe I can factor out 3 and x. If I factor out 3 and take away an x, remember it's divide and subtract, plus, plus. I have 3 terms, so I'm going to have 3 parts inside. Remember, you're dividing out of 3x from everything. Divide out of 3x, divide out of 3x. You're going to divide and subtract. 4, x to the second when you subtract x's. 3 goes into 15 5 times. There will be 1x. And then 3x divided by 3x is a 1. Don't forget to put the 1. I think this may just factor again. 4 and x, and then 1 and 1. And I'm going to add to get the middle term. And that would be 1x. That would be 4x. Sure enough, it does add to get 5x, so it checks the middle term. So this one was factored twice, and now it's factored completely. 3x parentheses 4x plus 1. All right, my next part. We begin our unit 4 and 5. Some of these numbers of some of the problems might not match perfectly, but all of the items that you're going to check are the same as what you have on your review. Quadratic equation must contain each of the following. Well, by nature, quadratic implies x to the second must be there. Number 2, all of the following refer to the same thing except for which one? X-intercept solutions, constants, or zeros? Constants is not. We don't have a constant. X-intercepts tells you where it crosses the x-axis, which is like solutions and zeros. You also have another word. They're also called roots. So if you say roots, zeros, solutions, or x-intercepts, you're all talking about where it crosses the x-axis. So that's what I'm going to refresh with you on number 3, which one of these match. So when it talks about solutions, we're talking about where it crosses the x-axis. All right. Letter A only touches one spot, so that would match one solution. Letter B, notice it doesn't quite come up far enough to touch X at all. So this one does not touch X. Since it does not touch the X-axis, this one has 0 solutions. All right. And then the last one here, it actually touches at -2 and +2. So this one actually gives us 2 solutions. 2 x-intercepts, 2 roots, 2 zeros. Any of those phrases could be reused to the same thing. Both numbers, okay? I'm going to, for a second, I'm going to ignore the negative and I'm going to use the +6. +6 subtract 3. That would give me +3. Then I'm going to hide the plus sign and I'm going to use the negative. That's -6 minus 3, which is -9. So I'm going to get 2 answers. I'm going to get 3, -9. Now, I actually am not finished. I need to divide by whatever number's in front of x. That actually means both solution of numbers gets divided by 2. So I actually get 3 halves and -9 halves. If you change those to decimals, you would get 1.5 and you would get -4.5 if you had to change those to decimals. I'm fine with the fractions. All right, next problem we're going to move to is one that's labeled 13. We're going to use the quadratic formula. So when I use my quadratic formula, a turns out to be the number in front of x squared, so a is a 7. B is the number in the middle, so B happens to be 10, and C is the number with no x, and it happens to be 2. Now I'm going to substitute into the quadratic formula. We learned it with a song. Opposite of B, plus or minus square root, plus or minus square root, B squared minus 4AC, B squared minus 4AC, all over 2A, all over 2A. All right, so the quadratic formula is something you will have to remember. It's probably not going to be provided to you on the exam because I do not have an information sheet that you will be given. So hopefully this song is helpful if you need it. All right, so opposite of B. I always like to do opposite of B because that's telling me I'm going to have -10. 10 is already positive, so that's going to make it -10. Plus and minus the square root of B squared. And I like to square that number ahead of time, so 10 times 10 is 100. Minus the 4 that's built into the equation times an A number of 7 times a C number of 2, and then all of it over 2 times A, which is 2 times 7. All right, the first thing that I want you to do is I want you to get your calculator, turn it on. I have mine out and we're turning it on. The first thing that we're going to do is we're actually going to take and we're going to actually pull the numbers that are underneath the square root, but not the square root. Pull those out, type them in our calculator. So we have 100 subtract 4 times 7 times 2. So, whoops, looks like I didn't get the 1. Let me make sure I do that. And 100, there we go. Press enter, and 44. All right, so that tells me that this is going to simplify into 44. -10 plus or minus the square root of 44 divided by 14. That really doesn't match any of the answers. I've got 14 here, but it's -5 plus. So I'm going to say A is already out as a choice. I know that we should be able to simplify the square root. That should be 4 times 11. So what comes out should be a what? 2. So now I have -10 plus minus 2 radical 11. There's something else that you need to remember. 14 is a common denominator. That means it goes under the 10 and it goes over under the second term as well. So I'm actually going to have over 14 over 14. If possible, I will simplify the fraction. 10/14, 2 goes into both numbers, and I should get negative 5 over 7. All right, 2/14, 2's on the outside, 14's on the outside. I should get plus minus 1 over 7. And then, of course, I didn't do anything. The square root of 11 is still there. Now, if we bring this back together, does it match any of our choices? Well, once I factored it down to 7, I no longer have negative 10, and I don't have 39 under the square root. It actually matches when we check it. We're going to do negative 5 minus and negative 5 plus square root of 11 divided by 7. So C is the correct answer, and I had to simplify and work within my quadratic formula. I just gave you an example to make sure that you had to go back and had to use the quadratic formula. 14. We're going to solve by completing the square. This is something that we did this year, something I've added to the review. When you do completing the square, you remember one day we talked about completing the square, and we would talk about having maybe big sections, and then we would have some small boxes here, and maybe we'd have a long box there, and we would say, how many do we need to add to complete the square? Okay, so we may have to add some pieces. Well, that's what we're talking about. To complete the square, I'm going to half the middle number and square it. So half of 8 is 4. 4 squared is 16. I need 16 and I have 7. So the first thing I'm going to do is I'm going to actually move 7 out of my way to the other side of the equation. So I'm going to have x squared plus 8x, and I'm going to leave some space, and on the other side, when I move 7 over, it became negative. Now, we just said that if you half 8 and square it, you're going to need 16. So I'm going to come in here and I'm going to add the number I need to complete the square. Well, if you add it to one side of an equation, you're going to have to add it to the other side of the equation. So this is going to factor now, and hopefully it's a perfect square. X and x, 4 and 4, plus plus. Since the two parentheses are the same, it's x plus 4 squared equal to, now we have to deal with the other side. Negative 7 plus 16 is 9, so now we're equal to 9. Now I'm ready to complete the square. I did that, and I'm going to solve it by getting rid of the square. So the square root and the square cancel. You get x plus 4 out, but x plus 4 is equal to square root of 9. Square root of 9 is 3, but we can't forget what? When you take square root on the very next step, plus or minus. Now, to finish this, to get two answers, I'm going to bring this over. When I do, then positive 4 is going to become negative 4. I have to do both of these numbers to get two answers. First, I'm going to use the positive 3. Positive 3 minus 4 is negative 1. Then I'm going to take the negative 3. Use negative 3. Negative 3 minus 4 is negative 7. So I have two possible answers, negative 1 and negative 7. All right, number 15, solve by completing the square. So another one, same thing. Let's see if you can remember. If you want to challenge yourself, pause the video. All right, we're going to work together. I'm going to move 100 over there. X squared plus 16x. When I move 100 over there, it turns out to be negative 100. Now, I'm going to look at the middle number. We're going to half it, then square it. Half of 16 is 8. 8 squared is 64, so I'm going to add 64. If you add 64 to one side of an equation, you're going to have to add 64 to the other side of the equation. This should factor into two parentheses just alike, x plus 8 and x plus 8. Negative 100 minus 64 is negative 36. I can rewrite x plus 8 as one parenthesis squared is equal to negative 36 because I was trying to make it become a perfect square. Now, to undo the square root, I'm going to take the square root of one side and the square root of the other side. This side I know I get x plus 8. Something interesting happens on this side. For the first time in my review, I have run across a negative underneath the square root. Do you remember what the square root of negative 1 was? This is the first year that we've had to talk about imaginary numbers in Math 2. Square root of negative 1 comes out as imaginary letter I. It's the only imaginary letter we have. So the negative comes out as an I. So I know I'm going to have an I here. It turns out the number part, the 36 part, that's 6 times 6 or 6 squared. That's going to come out as a 6. So not only does an I come out, but the 6 comes out. And remember, don't forget what? Plus or minus. So one step to go. The only thing I need to do now is I need to move 8 to the other side to get x by itself. It's going to become a negative 8. So x is equal to negative 8. And then I'm going to keep the plus minus that was in front of 6i. Because that has an I, it cannot be added. You cannot add that to get 14, or you can't do it like negative 8 minus 6 is negative 14 or negative 2. You cannot add it. You have to leave it just like that. All right. When we start the next section, this is Unit 5. This is the new small unit I added that was application questions. And so a lot of these, you can use your calculator. So make sure you get your calculator out. Make sure that you open it up. Make sure y equals, clear anything out. Make sure that plot 1, if it is black, make sure that you turn those off. So like I'll press enter, and when I go back down, nothing up the top is highlighted and y1 is clear. All right, first thing we're going to do is we're going to type this equation in our calculator. Negative 20.8 x squared, here's the shortcut key for x, it's up here next to the alpha, square, plus 458.3x plus 3,500. All right, make sure double check that you have it typed in correctly. Now, my question says, suppose that equation represents the cost of a car between 1964 and 2000. X represents the years since 1964, so I'm going to keep that in mind. Which year has it had the greatest value? So I'm focused on the greatest value. So I'm going to go to my table. So if you want to jot some stuff down, we're going to use the table. So put the equation in y1 equals, then we're going to use the table. So that just kind of lets you know where we're going. So now I'm going to go to the table, and I'm going to go back and make sure mine starts at 0. So at 0, looks like my value, my cost was 3,500. Then it went to 39, 43, 46, 5,000, 52, 55, so it's increasing, 5,600, 5,800, 5,900, 6,000, more than 6,000, came back down to 6,004. So it looks like it happened at year 11. Do y'all see that it happened at year 11 when it had the maximum? And now if I keep going, my value of the car is coming back down, so it's getting older and older. So at the table, it was at X11 where it was the greatest value. So my answer would be 1964, and it would be 11 years since 1964. So if you add those 11 years, you get 1975. That was A. My chance at choices at A. All right. Number 17. The ball is kicked off the ground after 5 seconds. Its height is given in an equation, negative 16t squared plus 64t. At what time does the ball reach its maximum height? We can do this with our calculator. Go to y1, clear out the old equation. So here's what I'm going to do. It says, after 5 seconds, its height in feet is given by the equation. At what time does the ball reach its maximum height? So we're going to go and we're going to type in the equation, and my equation's negative 16t squared. I don't have a t, I'm going to use x square, use a shortcut key for square, plus 64t, which I'm using an x. So x represents time, h is represented by y. Okay, so I don't have h's and t's, I have y's and x's. So that's time and height. Now, I'm going to look at my table. If I look at my table, I'm going to have to go all the way back up to the top. It looks like at 0 seconds, I'm at 0 height. At 1 second, I'm up to 48. At 2 seconds, I'm up to 64. At 3 seconds, it looks like I'm back to 48. At 4 seconds, I'm back to 0. So this looks like a perfect up and down motion from 0 seconds to 4 seconds. Now, looking at your data table, what time does the ball reach its maximum height? So this is pretty symmetric. So it looks like it reaches its maximum height at what? 2 seconds. And at 2 seconds, we're at 64, and that's the highest that you'll ever get. You can change your window. We will not look at negative time. We're only going to go for up to about 5 seconds, give ourselves a little baseline. This thing, I'm just going to put 50. And let's just take a look at our graph. Looks like it goes higher than 50, but looking at it, if I change my Y height, Y max would represent the maximum height. So let's just change it to 100. It's just review. So I can see that it comes up as high as it can go. So by the time it leaves the ground, goes up to its height, it's at 2 seconds, and then it's back down. It didn't ask me what the height was. It just said, what time does it reach that height? It reaches it in 2 seconds. All right, 18 and 19 are kind of real short, quick answers. Nothing that you actually have to calculate. You just got to realize what you have. If you will remember, there is a basic formula for the height, and it's usually got negative 16t squared. Then it will sometimes say v sub 0t plus h sub 0. Those numbers that you see actually represent your initial velocity, or how fast it was going to start with, and the number at the end tells you its initial or its starting height. Okay, so all I'm asking you for in 18 is 19 is, do you recognize the information that's given to you already in an equation? So here's our function, negative 16t squared, 32x, 240, depicts the flight of a cannonball shot from a cliff overlooking the ocean. How high is the top of the cliff? In other words, how high is this cannonball when it's at the top of the cliff when they're shooting it off to begin with? I'm really asking you for the initial height, okay? And actually, there's nothing that you should calculate. It's a recognition of what information you have. 240 tells me the initial height because it's the number at the end that's already there when I begin. So number 18 is simply C. Number 19, same function, same height, cannonball from the cliff. At what velocity? Again, the number that's actually built into the equation, the velocity is always the number in the middle with the letter T. Do you know what it is? It's not 16. It's not 240. I'm not calculating 256. It's there for me to pull out of the equation and recognize what information they're giving me. So that's a review of how we actually make our equation. Number 20, a ball is dropped from a building. How long will it take for it to hit the ground if the situation is modeled by this equation? Now, if we look at this equation, I know that 16 is a reference. It's actually a nod at gravity. That's where negative 16 comes from. It's actually half of gravity's value. I do not have a t term, but I do have a number with no t. So that tells me that this is at a height that I'm starting out at 200. So this building must be 200 feet high, okay? And if I hold it out there and I just drop it, so it's 200 feet high, but when I drop it, its velocity to start with must be 0. So it's almost like you're just holding a penny out. You don't throw it up, you don't push it down, you just hold it out there and it's at 0 and you just drop it. So that's what we're talking about. That's the situation, and that's why we don't have a middle term, because you have 0 initial start speed. Okay, same thing with my calculator. Type it in our calculator. Go to y equals. We're going to change the equation to say plus 200, because that's the start height. That's my new equation. And my question says, how long will it take for it to hit the ground? All right, I'm always really fond of looking at the table. So it looks like at 0 seconds, I'm at 200, then I'm at 184, then I'm at 136, then 56, then negative. What happens, what does it mean when you're negative? It means that you've already hit the ground, and if you could actually plow into the ground, you'd be 56 feet underground. Obviously, that's just an interpretation. So it looks like somewhere between 3 seconds and 4 seconds, I've hit the ground. Now, I think you could probably figure that out between your choices. It's not 5.6. It's actually what? 3.5. Now, if you wanted to look at this on a graph, I like to make sure that you know how to change your window. So we're going to press window. X represents time, and we know that by the time this thing has gone 5-6 seconds, it's already back on the ground. So we'll just put 6 to give ourselves a little extra space. And we know that this thing starts at 200. Now I'm going to leave myself negative 10 just to see a little bit below, just to give myself a little space. This is a graph. Didn't work out that way. Oh, 2000. Didn't mean to do that. All right, here's the ball coming down. And if this is marked off 1 second, 2 seconds, 3 seconds, 4 seconds, when does the ball hit the ground or the object? Between 3 and 4 seconds or 3.5 seconds. All right, 21. The product of two consecutive even integers. These are the product problems that we've been working. So it's in our applications chapter. You saw them in Math 1. You're seeing them again in Math 2. We're going to go phrase by phrase, and we're going to write our equation. The product. Product means we're doing multiply problem. All right, we have talked about that the product means multiply. Then it says of two consecutive positive, well, I'll kind of keep that in my pocket for a minute, even integers. So I know if it says even, it's x and x plus 2. So I always like to write those on the left-hand side just to remember what they are. Now, I'm going to multiply these two positive consecutive even integers. So if I multiply these two, I know this is going to be like the first one's x and the second one is x plus 2. So I'm going to multiply these. Eventually I'm going to have to do distributive property. The next thing I see is. So is interpreted as an equals. Then I see where it says 6 more than. So I'm going to add 6 to something. It implies more than something. It implies there's something there first, and it's 6 more than that. 6 more than 3 times. So 3 times, okay, their sum. Sum means to do what? Add. And we're talking about their sum. So we're talking about summing things up, and I'm summing my two numbers. So I have to come back over here and add. So what is x plus 2? Well, when you add the numbers in front. So you're going to get 2x plus 2. That would be the sum of the two numbers. So that's what goes here, 2x plus 2. This part represents their sum. So it's all about interpreting one phrase at a time until you kind of get your equation. Now we're going to solve it. I'm going to x squared plus 2x equal to 6x plus 6 plus the other 6. And that's going to actually end up giving us 12. Now, our strategy whenever we have quadratics is to move everything to one side of the equals and set it equal to 0. So I'm going to bring 6x over here. That means it's going to change to negative 6. And I'm going to be 12 over there, which is going to change it to negative 12. So now I have equals 0. X squared plus 2 minus 6 is minus 4x minus 12 equals 0. Factor into two sets of parentheses. What two numbers multiply to give 12? That subtract to give 4. 6 and 2. The bigger number wins the sign, so negative 6 plus 2. Then we're going to do that strategy of split, set each one equal to 0. And I'm going to solve for two possible answers. The first one gives me x equals 6, and the second one gives me x equals negative 2. Now, because I need positive numbers, I have to discard the answer negative 2. So I know that my two numbers are going to be 6 and 8. So 6 and 8 are the integers that I was solving for.